We are the team from University of Moratuwa presenting vision-based traffic sensing and control, which is our undergraduate final year project. The traffic lights in Sri Lanka and other developing countries, they work on preset static timing. They don't change throughout the day. So they are unable to handle the traffic during peak hours. They switch off the lights and they put policemen to control them, which is not an ideal situation. Therefore, we propose a system suitable for developing countries, which is like we place cameras on 4 sides. We capture the videos like this. The videos are sent to a chip which stays in the junction itself, and we run our custom algorithms to detect the vehicles, then track the vehicles, measure the traffic flow, and then use our custom algorithm to calculate the green times, which are used to control the traffic. Our solution is a vision-based system, which is robust in day, night, and rain. So it is decentralized as an edge system, and however, you can control and you can look at the traffic from a centralized place. It is also mass manufacturable as an FPGA based system, and it can be easily installed. It is scalable, generalizable to any junction. The traffic algorithm is currently commercialized into a web-based app at abrookTech.com. The product development, we are making this device with the road development authority of our country, as well as we are publishing a research paper in a Q1 journal on state-of-the-art circuit design. This is the custom digital circuit we designed, which could accelerate up to 58 gigaflops to calculate the neural network. We collected the data this way. We actually built a data collection device with a GUI interface, which is remotely powered as well as wirelessly controlled. Then we trained our neural network and built this tracking algorithm, which can track vehicles using this first order prediction. So it's a custom algorithm implemented in bare metal C. It works well in day, night, and rain conditions as well. Based on the traffic flow, which is measured from tracking, we built a custom algorithm called the delta algorithm to calculate the green timing. It allows 100 to 300 more vehicles and reduces the per vehicle per cycle delay by 3 to 5 seconds. It also stabilizes very quickly, as well as now it's being extended to multiple junctions. We are also publishing a Q1 journal, state-of-the-art paper on chip design to accelerate neural networks. This is our web-based system where you can enter your credentials and you can upload a video. Then you can draw counters on the roads, select the number of classes that you want to check, and run the algorithm to measure the traffic flow. So this is targeted at researchers and our road development authorities of developing countries who can upload these videos and pay per hour. So we identify the market gap and built a system to satisfy that. Right, to summarize, this is our undergraduate final year project for a 10 credit module, and all 4 of us got A pluses. We also patented our system, which is currently under review at NIPO, the National Intellectual Property Office. We also won a gold award at NBQSA, and we have come here for EPICTA. We commercialized our counting algorithm as a web-based service for researchers and government agencies, and our performance beats 1.5 million rupees software. We already have multiple clients to test the system. Our research, which is state of the art, it's being published in a Q1 journal. It's currently under review, as well as it has better efficiency and lower power at 7 times low area. We are also publishing a research paper on vision-based traffic control, but it's yet to be submitted.